The National Electrical Code, or NEC, provides guidance on the number of metal-clad, or MC, cables that can be passed through a wooden stud hole. This information is found in Article 334.30 B of the NEC. The NEC limits the number of MC cables passing through a wooden stud hole to not more than 2 MC cables with an outside diameter of more than 3/8 of an inch, which is 9.5 millimeters. Therefore, the requirement for the maximum number of MC cables in a wooden stud hole is found in NEC Article 334.30 E, which specifically addresses metal-clad cables type MC. In addition to the NEC requirement, several other factors should be taken into consideration when running MC cable through wooden studs. Firstly, the size of the wooden stud will determine the maximum number and size of MC cables that can fit through the hole. A larger stud may accommodate more cables or larger diameter cables, while a smaller stud will have more restrictions. Secondly, the number of conductors in each MC cable will also affect the overall diameter of the cable. Cables with more conductors will typically have a larger diameter, potentially limiting the number of cables that can be installed through a single stud hole. Thirdly, heat dissipation is an important consideration. The cables should not be tightly bundled together to allow for proper heat dissipation. Overheating can damage the cables and potentially create a fire hazard. Ensure there is adequate spacing between the cables to allow for air circulation. Passing multiple MC cables through a stud hole can be challenging. Consider using a fish tape or other tools to assist with this process. This can help you to guide the cables through the hole without damaging them. When installing MC cable through wooden studs, it's crucial to adhere to NEC guidelines and best practices to ensure a safe and compliant electrical installation. Failure to comply with these standards can result in code violations and potential safety hazards. Article 334.30 B provides specific requirements for securing and supporting MC cable. The cable must be secured and supported at intervals not exceeding 6 feet. Additional support is required within 12 inches of boxes, cabinets, fittings, and other cable terminations. These requirements ensure that the cable is properly supported, preventing strain on connections and reducing the risk of damage. When drilling holes for MC cable, it's important to follow proper techniques to avoid weakening the stud or damaging existing wiring. Drill the hole in the center of the stud, away from edges, to maintain structural integrity. Use a drill bit size that is appropriate for the cable diameter, allowing sufficient space for the cable to pass through without excessive friction. Be careful not to damage any existing wiring or plumbing within the wall cavity. If necessary, use a stud finder to locate studs and avoid drilling into hidden objects. In addition to the NEC requirements, local building codes may have additional restrictions or requirements for MC cable installations. Always check with your local building department to ensure compliance with all applicable codes and regulations. Some jurisdictions may require permits or inspections for electrical work, so it's important to obtain the necessary approvals before starting any project. Proper planning and preparation are essential for a successful MC cable installation. Before starting the project, carefully plan the cable routing and determine the number of cables that need to be installed through each stud. Consider the size of the studs, the number of conductors in each cable, and the need for heat dissipation. Make sure to have all the necessary tools and materials on hand, including MC cable, connectors, staples, drill bits, fish tape, and safety equipment. Always work safely when performing electrical work. Turn off the power to the circuit before starting any work and use appropriate personal protective equipment, such as gloves and eye protection. If you are not comfortable working with electricity, it's best to hire a qualified electrician to perform the installation. In existing construction, there may be obstacles or obstructions within the wall cavity that can make MC cable installation more challenging. These may include insulation, plumbing pipes, HVAC ducts, or other wiring. Take extra care when working in these areas to avoid damaging any existing systems. If necessary, consult with a qualified professional to determine the best way to route the cables around the obstructions. After completing the MC cable installation, it's important to inspect the work to ensure that it meets all code requirements and is safe and functional. Check the cable routing, support, and connections to ensure that they are properly installed. Use a multimeter to verify that the circuits are properly wired and that there are no shorts or ground faults. Once you have verified that the installation is safe and compliant, you can restore power to the circuit and test the operation of the electrical devices. The NEC is updated every 3 years, so it's important to stay current with the latest code requirements. Changes to the code can affect the way NEC cable is installed and the materials that are used. Subscribe to industry publications and attend training courses to stay informed about the latest developments in electrical safety. Consider using cable ties or straps to bundle multiple NEC cables together, but be careful not to over-tighten them. Over-tightening can damage the cable insulation and reduce its ability to dissipate heat. Leave some slack in the cables to allow for expansion and contraction due to temperature changes. This can prevent stress on the connections and reduce the risk of damage. When installing NEC cable in damp or wet locations, use connectors that are rated for wet locations. These connectors are designed to prevent moisture from entering the cable and causing corrosion or electrical problems. Always follow the manufacturer's instructions when installing NEC cable and related components. The manufacturer's instructions provide important information about the proper installation techniques and safety precautions. Failure to follow these instructions can void the warranty and potentially create a safety hazard. If you are working with aluminum NEC cable, use connectors that are specifically designed for aluminum conductors. Aluminum and copper conductors can react with each other, causing corrosion and electrical problems. Aluminum connectors are typically marked with the letters AL or ALCU to indicate that they are suitable for use with aluminum conductors. When installing NEC cable in corrosive environments such as near saltwater or chemical plants, use cable and connectors that are specifically designed for these environments. These cables and connectors are made from materials that are resistant to corrosion and degradation. Use caution when working with sharp tools or equipment. Always wear gloves and eye protection to prevent injuries. Keep your work area clean and organized to reduce the risk of accidents. Avoid working alone when possible. Having someone else present can provide assistance in case of an emergency. Before starting any electrical work, take the time to assess the risks and hazards. Identify potential hazards such as live wires, sharp objects, or confined spaces, and take steps to mitigate the risks. If you are not comfortable working in a particular situation, it's best to seek assistance from a qualified professional. When working with electricity, always assume that the wires are live. Use a voltage tester to verify that the power is off before starting any work. Never touch bare wires or terminals even if you think the power is off. Electrical shock can be fatal. In addition to the NEC, other industry standards and guidelines may apply to NEC cable installations. These may include standards from organizations such as the Institute of Electrical and Electronics Engineers or IEE, the National Fire Protection Association or NFPA, and Underwriters Laboratories or UL. Familiarize yourself with these standards and guidelines to ensure that your installations meet the highest levels of safety and quality. Consider using a cable management system to organize and protect the NEC cables. Cable management systems can help to keep the cables neat and tidy, reduce the risk of damage, and make it easy to access and maintain the cables. Cable management systems may include cable trays, cable ladders, cable ties, and other accessories. When installing NEC cable and suspended ceilings, use supports that are specifically designed for this application. These supports are designed to securely hold the cable in place and prevent it from sagging or falling. Suspended ceiling supports may include J-hooks, bridle rings, and cable clamps. If you are installing NEC cable in a fire-rated assembly, use materials and methods that are specifically approved for fire-rated construction. Fire-rated assemblies are designed to prevent the spread of fire and smoke, and it's important to maintain the integrity of these assemblies when installing electrical wiring. Fire-rated materials may include fire-rated caulk, fire-rated sleeves, and fire-rated boxes. When installing NEC cable in hazardous locations, such as areas where flammable gases or vapors are present, use cable and equipment that are specifically rated for hazardous locations. Hazardous location equipment is designed to prevent ignition of flammable substances and to protect against explosions. Hazardous location ratings may include Class 1, Division 1, Class 1, Division 2, Class 2, Division 1, and Class 2, Division 2. Ensure that all electrical work is performed by qualified and licensed professionals. Electrical work can be dangerous, and it's important to have the skills and knowledge necessary to perform the work safely and correctly. Licensed electricians have completed extensive training and have passed examinations to demonstrate their competence. Hiring a licensed electrician can help to ensure that your electrical system is safe, reliable, and compliant with all applicable codes and regulations. Remember that this information is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer for specific recommendations and guidance on your particular project. Firstly, the NEC specifies the allowable fill percentage for conduits and cable trays. Secondly, it is critical to ensure that the total cross-sectional area of the cables does not exceed the maximum allowable fill percentage for the raceway or cable tray. Thirdly, this is to prevent overheating and ensure proper ventilation. One must consult the NEC tables for the specific fill percentages allowed for different types of raceways and cables.